One of the projects that's really cool to do on a CNC is this kind of relief carving, relief cutting, where when we're all done, the letters and objects are standing proud of the background. This is the kind of thing I'm going to show you how to do on this CNC. We're going to go through the programming, how to set this up, also how to create a perfect octagon like this. And then once we're there, we'll look at getting it on the machine and everything else we need to do in order to make this cut. Here's a list of everything that you're going to learn on this video. We're ready to run VCarve and work on the sign that we're going to create. So we got a couple things going here. We're going to create a new file. We're going to get our material dimensions in there. So starting with a blank slate here. Step one is to come over here to our menu on the left and create a new file. When we do that, we get this menu and it wants to know how large is the material that we're going to work with. So we need to know the size of the blank that's going to go into the CNC machine. So we're going to use a piece that's 14 inches wide, that's our x-axis, and 14 inches high, that's the y-axis. Now, even more critical, I think, is the thickness of the material here. Now remember that when we make our piece, we're going to cut all the way through. So we have to know how thick our material is so that when we tell it to cut through, it's going to go through but not miles through. So we want to measure thickness pretty finitely because we're working with MDF here. It's easy in this case because MDF runs a pretty darn consistent 3/4 of an inch. So that's 0.75. The other thing that the software wants to know at this point is where are we going to originate our file? So when we look at our finished board, we could have our XY 0 point down here at a corner. We could have it in the center, we could have it up at this corner, and it's just an it depends of how you're working with your piece, how you're going to position it on the machine itself. For this project, we're going to make 0x, 0y right smack in the middle. So when I come here, I'm currently set for the center. If I click there, that puts my 0, 0 in the lower left corner. So like I said, we want to stay in the center. If we needed to, we can change from inches to millimeters. A lot of options with the software, and we're going to go over some of them, but not all of them, because we just want to get you to a point where you can start setting some of this work up on your machine. In our case now, we've got our material on here. Here's our 14 by 14 inch board. Here at the center, that's 0, 0. So we're ready to start laying out our project. And what we want to do is put an octagon on here. Now we could grab a line tool and start drawing lines, but that's like me trying to draw a perfect octagon with a pencil. So instead, let's take advantage of what the machine is capable of and simply draw a polygon. When I come to that polygon menu, I can choose the number of sides I want. I'm going to pick 8 because we want an octagon. Then when I come to the next line, center point, where do we want this pivot point to be? And I'm going to put it at 0x, 0y, that's the center of our board. Then the radius is, if we drew a circle that circumscribes the octagon, how big would that circle be? Let's go just a little bit bigger than that. Let's try 5, and we'll see what we get over here. So when I hit create, that's our octagon. Now we could go just a little bit bigger than that. Let's undo. Because let's fill our workspace as long as we're doing this. We have a 14 by 14 inch board. So let's go with a 6 inch radius. That gives us our 12 inch octagon. Now what we've got here is the outside of our piece. This line is describing the outside of the octagon. And if we look at our finished piece, what we need to do is have our outside, but we also need to have an inside. The router bit's going to need to know where to stop when we create this ledge right here. So one way we could do that would be to click Control C, that's going to copy, doing that on the keyboard. Control V on a PC, that's the paste function. And then that gives me a second octagon. Now the problem with this is I'm manually controlling then the size of that second one. So the point of this is, does this work to produce a second octagon? Yes. Is it the easiest way to make this happen? No. So I'm going to delete the one I just resized, come to this one, and let's take advantage of what the computer offers and come over here to the menu to this offset option. And I can offset, and the menu gives me the opportunity to go outwards. I can make an octagon that's bigger. Inwards, make an octagon that's smaller, or both. And indicate just how much I want that offset to be. So let's call that 3/8 of an inch. And then this is pretty cool. When I hit offset, it automatically creates an octagon that's a perfect 3/8 of an inch smaller than the first one. And we can use that not just with octagons, of course, but with any shape that we're trying to create. We can take advantage of that offset. Now, part of what we want to look at here is if we go out to the World Wide Interweb and we bring in clip art, can we cut that clip art here on the CNC? And the answer is yes. So for our work today, I found a handsaw and this is the saw that we want to use. Now the problem is that this is a JPEG or some kind of a file like that, which means it's not a file that the CNC software necessarily recognizes. So if we have this sitting in the middle of our stop sign and we start cutting, the router bit is not going to know that this is the perimeter of our saw. So we've got to fix that. What we're going to do, we have to make this artwork what's called vectors. And it's pretty darn easy to do. What I can do is pick this, I can select this. Then when I come over here to my menu on the left, there's an option here to trace the bitmap. And don't worry about the tracing part, it's much easier than it sounds. I'm going to click that, I'm going to use that function. And then we get a menu here, and what this is allowing us to do is the software is going to look at the lines on the clip art and turn them into vectors that the cutting program actually recognizes. So I can change different parameters. I can make it more sensitive, less sensitive. I can bring in color. I can bring in black and white. Let's do a preview and see with the settings just the way they are, what do we get? So when I clicked on preview and these lines turned dark, those are the lines that are now going to become vectors for the computer to cut. And that looks like it came out okay. So now we'll click apply. Now, let me close. And what happens now, if you watch when I click on the saw, when I click out here, that's the outside of the saw, then there's one of the rivet holes, there's one of the rivet holes, there's the handle, the hole in the handle. And what I'd like to do, I don't want to have all these individual components, I want it to see the saw as a saw. I want it to all be grouped together. So I'm selecting all of that, and we can do that by dragging around it. Whoops, I missed part of it. There we go. Creating that rectangle around it just using the cursor. It's all pink now. When I come over to the menu on the left side, there's a group option, group selected objects. So when I click on that, now it's made all of those vectors a group, and when I move them, they're all moving together. Now a good question would be, well, what's this gray thing hanging out here? That's our original image, and we don't need that anymore. So this one that I was moving, those are our vectors, that's what we want. This one that was left behind, that's the original image. I'm just going to hit the delete key on the keyboard and make that go away. So this now turned into artwork that the computer is going to recognize when we start to do our cuts. Let's take a closer look at this because we can do make some changes to it here. I am scrolling in on my mouse. I'm rolling the wheel to magnify that. And I know that there's some detail here that we're not going to need. This inner line here is going to be superfluous for what we're cutting. So what I'm going to do is click all of this, turn it pink again. Now I can't eliminate just that inner line because everything is grouped together. No matter where I click, I get the entire handsaw. But there's stuff there I want to get rid of. So I'm going to get the whole handsaw by clicking on it. Then I'm going to come back to my menu and I'm going to ungroup it. So then it's going to see those now as individual components. There's the inner line, there's only the outer line. So that inner line I'm simply going to delete and let that go away. We're doubled up on lines here on our rivets. We don't need all those lines. I'm going to hit the inner ones and go away. Now, how do I know that we're not going to need this stuff? Well, part of it is I worked with this artwork once before, so I went through some experimentation to see what would work and what wouldn't work. And part of it is how small a space we would create. So I got to be able to fit a router bit into this hole when I go to cut it. So with that inner circle I had in here, it's smaller than what we need in order to make that internal cut with our router bit. Over here on the handle, we've got 2 lines in the original art. I'm going to eliminate the inner one. And that gives us cleaner lines now, cleaner objects for the software to handle. Now let's zoom out by rolling the wheel on the mouse. And I'm going to come back and get all the saw highlighted again. Make a big rectangle. There we go. And now, because I had ungrouped it, these are all individual components. Let's come back and group them again. That way, when I click on the saw, I can move it anywhere I want it. Whoops. And it'll move as a unit instead of just grabbing individual parts. Now, the other thing that's pretty cool is we can come up here to a corner. We can make the saw littler. We can make the saw bigger by dragging. We can also come up here on a corner, if I get in just the right spot there, and we can pivot it. So we can manipulate the artwork once it's in to get it where we want it, the size we want it. We can make it do what we want it to do. Because of the angles on the side here, in this case, I like for the saw to also be at an angle like that. I think that's kind of cool. All right, so let's add some text to what we're doing here. And one of the things we can do is we can use the software to create parameters to help guide our layout. I'm going to come over here to the left side and I'm going to get this rectangle tool. And in this case, I'm not going to lay it out on the menu. I'm going to lay it out manually because what I know is I would like my letters to fit in about that much space. So I'm messing with it a little bit here just to get it the size that I want it. And this is just a temporary device. This rectangle is just for layout to help me get text that will fit in this part of my sign. So I'm going to highlight that, the layout rectangle, and come back to my menu on the left for a text tool. Now there's 2 of them. There's draw text, and there's draw text within a vector box. Which one do you think I should use? Well, let's go inside the vector box because I have a vector box. So that's going to control the size of the text. Now my sign says George's Shop, and I've already got one of those, so we're going to do Sam's Shop. Type Sam, enter to get on the next line, shop. And down here, there's about 80 bazillion options that we can use for different types of text when we lay this out. So you can experiment with this, you can change the layout, you can change the text, we can align it to the left, we can align it to the center, we can align it to the right, a lot of different options. I'm going to go with center alignment, and we're going to stick with the Garamond text that we're using now and apply. And then see, that's pretty cool because I've already got that rectangle there. It fits the text into that rectangle. If I didn't have the rectangle there, it might just plant the text huge on there. Not a huge deal, and I'll show you why. Because let's say that happened. There's my text. If it's too small, I can make it bigger. If it's too big, I can make it smaller. I can move it if I want to move it. So there are after the fact options, but describing the area, defining the area with that rectangle just helps you focus in a little bit on getting it right on the first try. The rectangle was just a layout device, so let's get rid of that. And now that I look at this, I think the text could be a little bit bigger because Sam's got bad eyes. We want to make it easy for him to read. And I'm just manually repositioning it to get it to where it looks nice in our drawing. Our layout is complete. Now we're ready to do some cutting. Now this is pretty cool. These letters are cut such that the background is relieved, and that leaves the saw and the letters standing proud. So let's do that step first. What we have to do is tell the software where to stop. Where does the carving originate? Where does it end? So we're going to do that by clicking the inner octagon. That's our border out here where we want the relieving to stop. Now as I click another area, I want to keep the letters too. I don't want it to just blast through those. If I just click the letters, it unclicks the outline. So the key to that is holding the Shift key. Click the outline. That's parameter number 1 or borderline number 1. Hold the Shift key. Click the letters. Because those all went in together, they all highlight at the same time. And then we want to keep the saw. So I'm going to click this outline line of the saw. That's the stuff that's going to get left behind when we do our V-carve. Next, we're ready for toolpaths. When you open up this toolpath menu, it's nice to hit this little pin at the top, and that holds it open. If I don't pin it, then every time I come off of there, that toolpath menu wants to close again, and it's just a little cumbersome. If I pin it in an open position, it's going to remain open while we do this programming. So let's come back. Pink border, Shift key, pink letters, pink saw. And the function we're going to use is this one. We're going to V-carve. Now a couple things going on here. We need to pick cutters. For the V bit here, that's the cutter that we're choosing to use that's going to finish the cut. That's the cutter that will be right up against these edges and create that nice crisp corner. And I find that a 60-degree cutter works pretty well for that, but if we look at our menu, when we select bits, we can use a variety of different V bits in order to make that work, but the steepness of a 60-degree cutter works great for leaving good detail behind. Oops, because I didn't hit a bit when I was in here. 60-degree, half-inch diameter. There we go. Now, think about what's going to happen here. Your routing experience may have told you that if all I do is come in here with a 60-degree V-bit and I got to take all this wood out of here, it's going to take a lifetime. And it's a pointy bit, not a flat bottom bit. So what can we do to get material removed more quickly and leave a flatter surface behind than a pointy bit is going to leave? Well, that's the option here. Use flat area clearance tool. So if I click this, what's going to happen is it allows me to choose a tool that'll excavate out most of the waste. It'll get as close as it can to the letters and the saw and the border without messing them up. So when we select our cutter, this is a function of, if I go with a real small bit, it'll get in closer to the details, but it'll take longer. If I go to a real large bit, it'll go faster, but it won't get as close to the details. I'm going to go with a 3/8 inch bit, calling this an end mill. This is what we're used to using in our shop, just basically straight carbide or fluted or spiral fluted router bits. So a 3/8 spiral bit is what's going to make that cut. And then what we need to do is tell it how deeply do we want that to go. This is this number right here, flat depth. If we increase the number, then it's going to create a deeper, deeper, deeper profile. If we decrease it, it's going to back it off. 0.13, that's just a little over 1/8 of an inch. Let's leave it there, and I think that's going to work well for us. As we come down here then, with these file names, I like to make them descriptive for what we're doing. That's going to help me know which bit to put in. So I'm going to call this 60-degree V-carve. And then we're going to hit this calculate button, and you're going to see a bunch of lines appear. And that's laying out the cut that we just created. Now those lines don't really tell me much. It tells me the tool path, but that's visually not very helpful to me. So let's come back over here on the right side and preview the tool paths. And this is really cool. We're going to do a virtual cut on the computer. That's our 3/8 bit, followed by the V bit. Now, we've got a little bit of kerfluiness here because it excavated out this handle area. So let's go back and look at why that happened. I don't want to V-carve this. We're going to treat that a little bit differently later. So I'm happy with the letters. I'm happy with the border. I'm not happy with this. So when we come back and look, so the problem here is, remember I grouped our handsaw components so that I could easily move it. So when I clicked on this and that highlighted this, it turned everything pink. And what I really want to do is only turn the outside of this pink. So, easy fix. We're going to come back here. I'm going to select the handsaw. I'm going to ungroup my objects again. So now when I pick the outside, I only get the outside. And then we're going to pick our letters. And then we're going to pick our border. And I'm going to come back here and I'm just going to delete and delete. So we're going to get rid of that stuff that was incorrect. Come back here, get my outside of my saw, border, letters. Now these parameters I set initially are still there because we just used them. So all I need to do is give this a name. Calculate. Now we're still looking at the preview that was incorrect. So I'm going to reset that and I'm going to make all that go away. Preview the tool paths we have now. That's what we want. That's better. Except that we got the V cut, not the pocketing cut. So by clicking on pocket cut, that's the 3/8 bit. We'll preview that one. So that happened because there we go. So that happened because I did preview selected toolpath instead of preview all toolpaths. Now we can rotate this, and that's going to let us look at it crossways and see there's the depth of our letters. That's that 0.13 that we programmed into this. So is that enough? Do we want to make it deeper? Do we want to make it shallower? We could go back and redo all of that. Now let's come back here. We want to cut this out from our mothership. We want to cut it out from the main board. So I pick the outside. And on our toolpaths, we're going to use this one. We're going to use what's called a profile toolpath. And when I do this, this router bit is going to somehow follow this line. Somehow is defined by this. It can cut on the outside, can cut on the inside, it can cut on the line. On the line would be the bit is centered on the line. We don't want to do that because it would cut into part of our shoulder we're trying to leave behind. We don't want to cut on the inside. We want to cut on the outside. Up here at the top, we need to tell it how deeply to go. We want it to cut through, but on a 3/4 inch board, 1.3 inches would be too much. So 0.77, remember our thickness was 0.75. That's going to let us cut through. But now think about what's going to happen here. If I simply cut through, then on the last pass, our sign is going to come loose of the field, of the rest of the board. So we're going to use what are called tabs to secure everything in place. This will make more sense in just a second. I'm going to add tabs. I'm going to edit my tabs. And I get options up here. Let's go ahead and add, and we'll see how that looks. So here's what happened. These yellow dots are tiny bits of material that are left between our project piece and the main board, securing them together. After all the work is done, and we can see it on this one, after all the work is done, we can come back and cut those tabs out, sand or flush trim back to our work, and they're just going to simply go away. But it holds everything together until we're ready to take it apart. This is a lot of tabs we have on here, so I am going to increase the distance between the tabs just because we don't need that many. That looks better. Now let's say that turned out by our layout that it left you with a tab right on that corner. That'd be a little bit awkward to deal with because it's right on an outside corner. So at this stage we can manually grab those and push the tabs to wherever we want them. Here's one on the corner down here to make it work better. So you still, as a woodworker, got to give this some intuition. You've still got to give it some control to make sure it's going to go the way you want it to go. Close. Now let's choose our cutter. We're going to do this with a 3/8 bit. And there's some economy of movement. Remember, we're doing our clearance on the inside with a 3/8 cutter. So if we use a 3/8 bit for this, it saves us a bit change. So let's have a look at our work here. We're going to cut through 0.77, 3/8 bit. How many passes is it going to take to go through that MDF? It's set for 7. We can look at that and say, well, how does that look? 7 passes on a 3/4 inch board. We're cutting 0.11 per pass. That's less than 1/8 of an inch. I think we can go a little bit more aggressively. Let's reduce to 6 passes, cutting about 1/8 of an inch per pass. Let's go down one more. MDF machines pretty well, so we can do this in fewer passes and it's still going to come out okay. We've got our tabs. We've got our cut through. I'm going to change the name here so I know what bit to use. 0.375. And I'm going to call it EXT for exterior. Now this is a cool feature. It gives us a warning. You've set this to cut through. Do you know that? So if that was a problem, we'd go back and fix something. But in our case, we want to cut through. So this is a good thing. The blue line is our tool path. Let's preview that tool path, see if that looks like it's okay. There it is. The blue is where it's cut through. The tabs are where it's left material behind. Let's add some detail to that saw and we'll be done with this. I'm going to work my rivets, holding the shift key now so I get them all selected. And the handle hole, we're going to do what's called a pocket cut. That's this option here where it says pocket. So what this is going to do is create a little recess where those items are. Let's check our work here. 1.125, that'd be way too deep. We'd cut way through our material. Let's go 1/8 of an inch deep. This cutter is going to be too big to fit in those small areas. Let's go down to 1/8 of an inch bit. And we'll be able to tell if even 1/8 of an inch is too small. We're going to know that in just a second. And then the rest of this work is going to be just fine. Let's rename our file. 0.125, and that's some detail work that we're doing. Calculate. Now, check our work. Is it really doing what we want it to do? Are we getting the details? Let's preview that tool path. So here, Are we getting holes? Yes, we are. Are we getting a handle hole? Yes, we are. So in other words, if that cutter was too big, these holes wouldn't exist. It wouldn't have been able to cut them. So we could go back and make a change. Now let's go back and give this another detail. We want to create the detail for this line. We want to give that a little bit of definition. So we're going to click that. We're going to use this engraving option. And we want to be on the outline. We don't want to cut all of it away. We just want to cut the line. We're going to do this with a very sharp and pointed cutter. We're going to do it with a 30-degree bit. Comes to a really, really sharp and distinct V. Let's try that. And identify it here in our file name, 30-degree, and this is a handle shape. So there's our toolpath has been created. Let's come back to our view and see when we do that, 30-degree handle, preview our toolpath. There it is. It creates that line just around the outside of our handle to give it some definition. So that's all set. So next thing, let's save our work so we can get it out to the CNC itself. Click. This little thing that looks like an old-fashioned floppy disk is our save function. Now, one of the things we need to do is choose the correct post processor for what we're doing. And in your shop, once you're using that, it's going to default to that all the time. We're going to go out and run this on the Laguna. So I've got the Laguna post processor. I'm going to save my toolpath. I'm going to put it on that flash drive so we can then put it into the fob on the Laguna. I like to create a folder that identifies the project and then put the individual files inside that folder. So there's our 60-degree letters. That's the pocket cut. Now this says 60-degree letters again, but remember it runs twice. It does a clearing cut with the 3/8 bit, and then it does the detail cut with the 60-degree cutter. So all I'm doing is one by one, I'm clicking the file, save the toolpath. They're all going into the same spot. Now, to make things a little easier when we get to our work, I'm going to open that file up. 60-degree pocket, what is that really? That's our 3/8 inch clearance cut. So on this one file, I'm just going to call that then 0.375. And this 375 degree letters, that's going to remind me that it's for the lettering cut. So that's going to let me know once we start running that I need to be running the 3/8 bit there. This file can be saved. So you can run it again, or you can save it and change it a little bit, put somebody else's name in there so we can keep reworking that file if we want. Our flash drive is ready, and we are ready to head to the CNC. Before we can run the CNC here, one of the things we got to do is secure our work to the table. So we're going to take advantage of the T-track system that's in this one, and using these clamps, get everything secured down. Now, keep in mind, board size, project size. The board was 14 by 14. Our octagon was smaller than that. Of course, where I'm going with this is you got to make sure when you're using fasteners like this, they're well out of the way of your tool path. And these are going to be just fine. Now again, it works to hold it down only on the outside because we're tabbing the object, so it's not going to be cut completely free. One of the things I've done is I've already put in a 3/8 router bit, and you're going to see bit changes get made in just a little bit. But I've got a 3/8 router bit installed, and the next thing we need to do is get it in just the right XY0. Remember, we define that as the center of our project. I've got a couple pencil lines on my board, and we also need to get the Z-axis, the vertical axis, 0. All right, here we go. What I'm going to do is start out by getting the bit a little bit closer to the work. That's our Z-axis here. So I can bring the Z down And that's just going to make it easier to tell when I'm actually over that origin, over my 0, 0 point. And then with our Y's and X's, we can move the head. So that's going to let us jog it until we're over our center point. Now in this case, we've got quite a bit of waste wood surrounding our project. So if we're plus or minus a 1/16 or an 1/8 of an inch, it's probably not a huge deal. That looks pretty good for positioning. Now I can hit X, Y, 0. And that tells the machine that that's the 0, 0 point in the X and Y. We haven't done the Z yet. But that's a 0 point now for my X and Y. Now for my Z, I'm going to raise this up. I need a little clearance. And we're going to use what's called a touch plate, touch pad. So this is going to go under our cutter, and then it plugs into the machine itself. So what happens is the machine knows just how thick this is. It's going to recognize the closing of a circuit when the bit touches here, so that it's going to tell the machine when it's zeroed in the Z axis. So touch plate goes under. Then we'll come back to the fob, and I'm going to hit 2 buttons at the same time here. It's going to find that plate. Now the reason that a Z doesn't read zeros is because our cutter is now above the workpiece by this amount. So as it comes down and it's at the surface of the workpiece, that Z would zero out. That takes care of our setup. Next thing, we're ready to actually start running our work. So we got to bring the flash drive out that we saved on. And then we're going to run. And it's looking for the flash drive. That's our U disk there, USB. So that's okay. Now we have different files on the flash drive. The one that we created for this project was shop sign. And when we go in there, this is a listing of all the files that are available in the shop sign. Now remember how I said I like to name the files with the cutter so that when I get here, I know what I'm doing? This is why. 375, well that tells me I need to have a 3/8 bit in there in order to run this one, a 60-degree bit to run that one. So that helps me just keep track of what I should be doing. I'm going to close the dust collection door, and we're going to be ready to start running this. We've got the correct file highlighted. That's our 3/8 bit. Hit OK. And then OK again. It's going to go through a little countdown. Get our dust collection running, and we're cutting wood. We're all set with that first pass. Now, let's talk about something here. We're going to come in, and because the 3/8 bit is already in there, and it's zeroed out in its Z, we're going to go ahead and run the other 3/8 file right away now. Now, when we output these, when we exported them to the flash drive, we could have run these together. We could have exported them together, and they would have automatically run back to back, and that's just fine. It would have saved us stopping at this step and calling up the next file. Here we go. Now it's going to cut the perimeter with those tabs. That takes care of our 2 cuts that are done with the 3/8 bit. So let's come back Here, I'm just going to make my bit change a little bit easier by bringing the head to me. And the 3/8 bit is going to come out. And we'll do our V bit next, the V-carve cutter. That's that 60-degree bit. So when it comes to changing cutters, this is very much like dealing with a conventional router collet. We're going to lock up the shaft. Loosen the collet nut. Now in this case, we're going from a 1/2-inch shank to a 1/4-inch shank. So pop the collet. New collet goes in. And then the only other thing we got to keep in mind is we've changed bits, so we've lost our Z0. Our X and Y0 are still just fine. But we have the technology to take care of that. There we go. It's going to hit that touch plate, give us our Z0, and then we're good to go. Now this is going to be second verse, same as the first. I'm going to run. I'm going to get to that file. I'm going to get to the V bit. There it is, 60 degree. We'll call that one up. Okay. Okay. Ready to run. V-carve's done. I think this stuff is so cool because of the way that the program allows it to come down, kind of ramp into the cut and really incise, really cut those inside corners. Really looks like it's been hand carved. Here's what I'm going to do. I'm going to change to the 1/8-inch bit. This is stuff you've already seen. This one will come out. The 1/8-inch bit, which is also a 1/4-inch shank, will go in. I'm going to re-zero my Z. Then we'll take off and do the cuts that the 1/8-inch bit does. Then we'll come back and do the 30-degree bit change, and that's going to wrap this up. So a bit change here, and we'll be back and running again. We have one more cutter change, and then we're going to be done with this. But I want to show you this one. This is pretty cool. Here's our 30-degree bit. Very, very pointed tip. It's really going to let you engrave a very fine detail. And interestingly, it's an 1/8-inch shank router bit. So we're going to change our collets again in order to run this. This part you've already seen. We're going to change collets, change bits, 0 our Z, and then we'll run our last piece of software. Going to call up our 30-degree bit. There it is. It's already zeroed out, ready to go. All right, let's have a look at what we've done. There's our finished sign. So pretty cool. Clip art off the web, brought in, did that bitmap to change it into vectors that the software will recognize. And not only did we cut that saw, But look, right there across the bottom, there's actually the teeth of the saw that were cut in by our V-bit. We've got our handle details. Now here's what had happened next for me. I would take this to a bandsaw and I would cut through those tabs, leaving them proud of the edge. Then from there, you can either use a flush trim router bit to trim the tabs completely off, or you could sand them off. Now, this is MDF, and lest you think we can't make a silk's purse out of a sow's ear, the sow's ear being MDF. Let me show you a couple examples here. This is also MDF, and that was sealed with shellac, and that does a great job of handling the porosity of the MDF. And then it was overcoated with what's called beaten copper spray paint. So it gives it that look of a hammered piece of metal when it's all done. This one, it's got a little bit of an antique sort of look to it. That was sprayed with a beaten copper, then sprayed with a green, and then with a paintbrush, just kind of wipe through that to cut loose the green a little bit to reveal some of the copper that's below it. And this one was sprayed with an aerosol product that's designed to look like stone when it's done. So what's cool about MDF is it's very inexpensive, so it's a great material to practice your CNC work on. And realistically, if you finish it correctly when it's done, it doesn't look too bad. So a lot of new information here on this project. Covered a lot of ground with the V-carve, importing our artwork, bitmap work, setting up here on the CNC. This follow along click by click will give you a really good project you can do in your shop with your CNC.